forgot my Ski Masters. Ski Masters, the throwback too. It's like a song, the throwback Ski Masters. Oh.
Like a lot. Like a lot.
It's a little big.
Oh my god.
Well, yeah, every jersey has that.
Bro, why do girls always want oversized?
I didn't buy this.
Oh,
Someone just was like, yeah, you can buy this one. I was like, okay.
Katie got one. I was like, well, do you want like one that fits? She was like oversized. Yeah.
No, her and Joseph are twinning, so that's really awkward.
Yeah, that's funny.
Morgan takes the DOCs at 7 a.m.
Yeah, I don't know that I want to take it, honestly. Like, what?
Boy, I thought your sister worked at
You heard about that?
I took her application.
No. Okay. Okay, what do you think about it?
What?
Yeah, right. Like, I really care. Like, it's like,
What do they say about big hands?
What am I gonna do?
Big gloves.
nothing, I don't know. She'll be for
Get it?
How often do you work?
Did you guys win yesterday?
Oh, yeah, you know.
Bro, that was the most boring meeting ever. I lined up twice and then got taken off.
Was it like
No
20
work.
€0?
She'll be there for like 30 hours.
No, but you. Thank you.
I swear, I
Oh,
was.
Donovan Mitchell.
5 to 11:30 at night.
Even though that is
Out of jerseys. I have like 7 jerseys in a day.
I forgot my throwback Steve Masters.
Thursday. I go and lift after and I get home.
Also have an Allen Iverson Jordan on jersey.
You have a, dude, you could have gone for it.
That's a college one. Is that LeBron or Michael?
Bugs Bunny. No, it actually is Bugs Bunny.
I feel like that suits.
Hey, Michael.
That's good.
Mr. Strauss, I
Yep.
wasn't here on Friday. Could I have my test back?
Sure. In fact, I wish I would remember to hand these back.
I know it really takes hurt.
Oh.
I'm just gonna hand stuff out.
Yeah.
Dude, and then he faked his injury in a different spot to be in the camera. Yes.
Not my goat.
Not my God.
When we watched that video on social media marketing, it was like that goat saving the pig or whatever. And I was like, yeah, Michael Jordan just saved that pig.
Bro, when Giannis got canceled yesterday,
Yeah, I
to come by
know.
a reset, I was like, I can only imagine.
If that was LeBron, dude, it'd be like
Are you ready
3
for
times.
He's probably still
the
been on
6
the
math
bench today.
test? When is that? Thursday? So I just don't have to do it.
LeBron,
Because,
or
like,
Giannis gets the shot.
No, I actually do not understand this one. Like the last test, I got 100%, and I like didn't think I knew anything on it.
I did that one good, but
Right, but then on this one, I'm like, okay, I don't actually know anything on it.
What is this? Oh, let's go. This one.
How you doing, Jader?
Wait, what did you do?
Oh, the past test?
No, what did this?
Mother Massachusetts. Oh, you missed it, dude. We lit stuff on fire.
Yeah, I know.
Great.
We had a little trouble.
Huh?
The lab.
The lighter?
Just a little. Bro, I dropped it right into the top of the tail. I would have been fine if it didn't go all the way up the seat. We'll check to see that your other stuff is coming.
Oh, God.
It's like an AP test, but it's not. It's
You all seen that or what?
but it's just for
I'm trying not to listen to that too much, so I have only.
No, I'm just like, I'm just gonna bomb.
I'll just
She
go
already
and
like,
find it.
like, I thought that was the plan for you anyway. It's like,
Wait, what test?
this EOC test, it's like an AP test but for HBS. Yeah, you know what that, yeah, yeah.
What do you even get for like topics?
College credit.
Credit, I mean. Or like a dual credit.
Dual credit. Sounds good.
I don't really know.
I don't know.
It's at 7 a.m.
Yeah, that's
Huh, you think I'm gonna be ready at 7 a.m.? Probably not.
yeah, it's pretty well down.
I know, like 7 a.m. like 7 a.m. doesn't seem that early, but like to actually like be ready to like
Just
learn.
gonna get ready, bro. Just take it.
What?
Yeah, that's what I said.
I'm off the wall. I drink.
So what's your plan for next year, Megan?
Yeah, I know.
I'm going to
Awesome. So you're gonna move out or you're gonna stay at home?
Sorry,
You gonna stay at home or are you gonna move out?
I can't move out because I own 2 bunnies and they live downstairs. Like,
Oh, you wouldn't.
I
And
don't have a lot of money to like.
And I was-
move out. Like I have money.
no, I was gonna say, plus you'll save a lot of money.
Yeah.
Live at home as long as you can.
And my brother lives with like.
Oh, yeah, no, I was gonna say, stay at home. So then put as much money as you can away in the bank. Make your parents pay for everything. All right. I gotta get this going here. How you doing, Ian?
I'm good. How are you?
How you doing, Chloe?
I'm good.
Sure.
I don't actually know how to look at this.
Yeah.
How you doing, Amanda?
Good.
Good. Avery, I can send you to somebody, but I just can't send you out of class. I can send you to somebody, but I can't just send you out of class. So do you want to go talk to, who's your counselor? I could send you there.
I think he's watching on the school.
Well, I can send you there and they can find him. So we're gonna get started in just a second here, Andrew. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. So why don't you take out your homework? We're going to go through it momentarily. The 1, 2, 3A, B, 4A, and B, and then the Boyles, the other problems. There's one without a name, so it's probably yours.
All right, you're all good. I do have one lab that's on it. Everybody not get their butane lab back? Everybody in the class got this back. Maybe it's somebody at home. Alrighty, so first off, don't forget to bring in your silver bottles. We're gonna do the lab next week. No, not next week. The last day of school, which is the 8th? 9th. So the 9th. The day before, I think what we'll do is we'll do half instruction and the other half we'll do day of explosions.
Yeah.
Okay, I'll just blow some stuff up.
That's what I'm talking about.
Hopefully I don't wreck the new school because they'll get angry at me.
Fine, I'll find it for you.
I won't be here the 9th.
The silver bottle lab is just a fun optional lab. Okay, it's no points, it's not a homework, it's just a fun thing if you want to do it. Then the second thing I was gonna say, if you want to do a retake, let me know and I will set up a time and a place for you to do the retake. So that goes for you Zoomies at home as well. So I really recommend you study before you take the retake. Otherwise, the grade is not going to change. All right. Any questions from anybody? The Zoomies, the Roomies? Okie dokie. So let's go through the homework then. Oh, I gotta share my screen. I don't think I claimed host. There we go. Is there someone in Zoom? Oh, we're all good. All right, when I was looking at the homework, it looked like you guys understood what you're doing. So we'll go through some of the problems. We're not going to go through every single one. So when we look at gas laws, oh, you don't want to see that? All right. When we look at gas laws, there are 4 variables, Abraham. Pressure, volume, sorry, not R. Pressure, volume, moles, and temperature. Those are the 4 variables. So when we studied Boyle's law was P1V1 is equal to P2V2. So in that law, we're changing pressure and volume, but moles and temperature are constant. So for Boyle's law, we're changing P and V, we're keeping N and T constant. Okay. So when we look at number two says we've got oxygen gas at a pressure of 101 kPa. It tells me the temperature is 25 degrees Celsius. Why did they tell me the temperature? Yeah, just to prove to you that the temperature is constant. They weren't trying to make it more difficult, but sometimes scientists do. I got 5 decimeters cubed. And my V2 is 10 decimeters cubed. So the first question I want to ask myself here, Chloe, is what's happening to my volume? Is my volume going up or down, Chloe?
It's going up.
Okay, if my volume is going up, what's going to happen to my pressure, Evan? Pressure goes down. So it's inverse. When one goes up, the other one goes down. So my new pressure should be smaller than 101. So Lily, you always want to ask yourself that question before you do the problem. Then we write the equation. Then we do the algebra. Oops, we're solving for P2. And this is why you don't cheat in your math class, because science has tons of math. If you don't learn your math, you can't do science. There's just no way around it. All levels of science eventually have mathematics in it, even biology. When you go up and higher in biology, there'll be math in it. Now we can plug in the numbers. The decimeters cubed cancels out. My new pressure is 50.5 kPa. Is that smaller than our initial one? Yeah. So then that's a good indication that we did it right. (3A). Our volume is 844 cubic centimeters. Our initial pressure is 98.5. We're trying to find the new volume. And they say the new pressure is standard. So that means, Abraham, you have to look up what standard pressure is. Eventually you'll have it memorized. Do you have it memorized yet, Abraham, or no? Do you know it, Alec? What standard pressure is yet? 101 Dalmatians. It's actually 101.325, but if you just want to go with 101 Dalmatians, that's a good way to remember it. So same formula. But now we're solving for V2. So Celia, what's happening to my volume? I'm sorry, just kidding. What's happening to my pressure, Celia?
It's going up.
Going up. So if pressure goes up, what's going to happen to my volume, Megan? It's going to go down. So now I can plug my numbers in. Oops, that cancels. And then my answer is 821 cubic centimeters. So did my volume go down? Yeah. Okay. The answer to 3B is 160 cubic centimeters. The answer to 4A is 280. And the answer to 4B, 0.805. I would like to do 4A. So for 4A, it tells us our initial volume is this. It tells us the initial pressure is this. We're changing the pressure to 104. And then we're finding the new volume. So whenever you do a problem, Lars, you should be presenting it like this, because it's not good enough just for you to know it. You have to be able to present it so that Abraham can understand it. Or actually anybody can understand it. Divide by P2. Now plug in your numbers. You don't just plug them in right away. We do the algebra first. And you should get 280 cubic centimeters. In a normal year, I would break everybody up into groups of 2. Each group would have a problem to present, and then we'd go through all the problems in class on the whiteboards. But it seems like things get pixelated a lot at home. So I'm just going to go through the problems instead of having you guys do it in groups. But normally, we'd have you guys doing these problems, not me. Charles' law. V1 over T1 is equal to V2 over T2. So of the variables, which ones are held constant in Charles's law? Pressure and moles. Charles's law, you change the temperature and the volume, you keep the other variables constant. Okay. In the butane gas lab, we use that equation. That's if you're changing all of the variables. So if you're changing P and V and N and T, then you use the ideal gas. If you're just changing temperature, use Charles. If you're just changing pressure, use Boyle's. And if you're changing all 4 of them, ideal gas. All right, 8A. (617 cubic centimeters). That's my V1. At all right, there's my V1. My temperature is 9 degrees Celsius. So temperature has to be in Kelvin. Unlike volume and pressure, we have to use the Kelvin scale. So you have to add 273 to it to convert to Kelvin. So in the gas laws, Morgan, you automatically add 273 to convert to Kelvin. Tomorrow's lab, you're going to find out why. Okay. T2 says to go to standard temp. So we'll go to our standard expert, Abraham Rice. So you know standard pressure, 101 Dalmatians. And T2 standard temperature. It's the number of girlfriends I had in high school. 0. All right. So standard temperature. It's all right. I made up for it in college. So no. So I did, never mind. All right. So oh, that's the T2. Sorry, that's not the V2. All right, so 0 degrees Celsius, Abraham. So then we have to add 273 to it. So we have our V1, our T1, and our T2. We're going to find V2. So V1 over T1 is equal to V2 over T2. So I do my algebra. And I get T2 V1 over T1 is equal to V2. So just like before, Emma, we want to do our predictions. Look at my temperatures, Emma. What's happening to my temperature, Emma?
Going down.
Going down. So if my temperature is going down, what's going to happen to my volume ion?
It's going to go up.
Ooh, trick question. This one is a direct relationship. So for pressure, if one goes up, the other goes down. But for temperature, if one goes up, the other one goes up. If one goes down, the other one goes down. Okay, so again, think of it, if you heated a balloon, it would expand. If you cool a balloon, it contracts. Remember, Tyler DeWitt said, go take a balloon, put it in your freezer, see what happens to it. So when we are done, our volume jitter should be smaller. Okay, it should go down. So we're going to put in our numbers. T2 is 273 times 617 divided by T1. The calculadora, and we get 597. So yes, the volume went down. That was 8A. 8B, the answer is 467. 9A is 3.80 cubic meters. 9B is 321 cubic centimeters. So I just want to do one more. Let's do 9A. So we got 2.90 cubic meters. That's V1. Our initial temperature is 226. T2 is 23 degrees Celsius. They want you to find V2. So I am not sure why here, Keith, they gave you the second temperature in Celsius, but you have to add 273 to it, Keith. How was your weekend, Keith?
It was good.
Did you do
Went
anything
to the
fun?
zoo.
Did you really?
Yeah.
I haven't been to the zoo in a long time. I want to go this weekend. We had soccer games all weekend. All right here. So what's happening in my temperature here, Sotera? It's going up. So then what's going to happen to my volume? Up. V1 over T1 is equal to V2 over T2. Whoops, I forgot to do the algebra. Sorry there, Finley. I'll do the algebra first. Now we can plug numbers in. So 296 over 226. And V1. The answer is 467. Nope, 3.80. So my volume did go up. Oh, someone knocking at the door?
Hello.
What do we got here? Oh, yearbooks. All right, I'm sorry, guys. We're gonna have to take a break to get your yearbooks. So please don't cry. We'll come back to chemistry. So for those of you at home, just for 5 minutes, meditate on the beautiful nature of chemistry while we hand out yearbooks. No, I do not. There we go. Thank you.
So you need to mark off who's actually here. If they are not here, they don't. Know.
Okay, so if you're not here, you don't get a book. Those aren't my rules, those are school rules. So let's see. RJ's here. Do you want me to mark off?
Yeah, so Drew Waller.
No, not here.
Keegan.
Keegan is over there.
Amanda.
Not here.
Megan.
Mike's here. Lars is here.
No, the fence is like 3 times 5. Oh, wait, you're a factory. It's on the corner.
Oh.
To me, I had a walk. Yeah.
RJ.
It's all girls there.
Morgan. I didn't see that. And I saw the last one. Evan.
What? You ordered? Wait, you ordered one, Alex? Let's double check your list there.
Andrew Waller.
So, I guess I would call it this Mortensen or?
Yeah.
So email us Mortensen.
And I gotta email someone?
Oh, come on.
Possible we made it into a different box.
Yeah.
Or a different day, because they're coming tomorrow too.
Oh, okay. All right. Well, maybe wait one day then. Okay, wait one day. Let's see. Okay.
Thank you.
All right. So, so I know you guys want to look at your yearbooks, but you've got to put them away. Self-control. You know, they say that if they measure your grit, that's what's the biggest predictor in your success in academics. Well, that's a tough thing to measure, grit, like your stick-to-itiveness. Are you the type, when things get difficult, you just give up right away, curl up in the fetal position and then cry? Or are you the type to, well, here's one way they actually measured grit. You gotta laugh at this research, but they put a marshmallow in front of kids, like little ones, like 4 or 5 or 6. And then they measured the time it took before they told the kids, don't eat the marshmallow, like wait as long as you can before you eat the marshmallow. Some kids, impulse control right away, boom, in the mouth. Other kids, they said, wait as long as you can. So other kids just sat there patiently and waited. So it's kind of measuring self-control. Now, granted, that's a big cry to measuring it from, adults or even, preteens, because you don't normally put a marshmallow in front of somebody and say, now let's see how long you wait before you eat it. You'd eat it right away, Finley? You just shove it right in your mouth? I forgot the exact, they did do something like there was a motivation or a prize. But again, some of that research you have to ask yourself, okay, is that really, maybe kids don't like marshmallows, Okay, one last thing I just want to point out on the homework, and this is having to do with algebra, Alec, okay? Because you guys, algebra skills, I'll be honest with you, this isn't a rip, it's just a fact. It's a little weak. So suppose we wanted to solve for T2. Okay, suppose you want to solve for T2. This is what I see happen a lot. I see people divide by V2, and then they end up with this. And then magically, T2 just appears in the numerator. You can't do that. All right, that's not right. Okay. How do I get the T2 into the numerator? Well, I can multiply both sides by T2. Then I get this. And then I can continue to do that. But the fastest way to do this, the fastest way to get T2 into the numerator is you can flip Charles' law. Just flip it. And then you can multiply both sides by V2 and you get this. Okay, so again, if you're cheating in your math class, really bad idea, because you can't do science, you can't do business. You're cutting your own throat here by doing that. All right, you have to learn this if you want to go on and get a career. So especially basic algebra. Also, if you want to know if something is legal, plug numbers in. So if you had this fraction, that's a true statement, right? If you flip it, is it still a true statement? Yes. So if you want to know if something is correct, plug some actual numbers in and see if it works out right. Okay? All right. So what we're going to do now is we are going to learn how to do Lewis dot structures for covalent. And then the last, this should take about 15, 20 minutes. And then the last 35 minutes of class, you're gonna work on your homework. And then tomorrow, the plan is we're doing another lab, okay? So you will need Appendix F and Appendix O. And a pencil. Don't use pen. Trust me, Lola, you don't want to use pen. Appendix F and Appendix O we're going to use.
What is this called? Like, what are we learning about?
Lewis dot structures for covalence. You guys at home ready? Appendix O comes after Appendix N. So first I'm going to review Ionic with you, okay? Because it's been a few days. So how do you know if something is ionic or covalent? You look at the electronegativity difference. If it's 1.7 or greater, Lily, it's ionic. So I put my magnesium in the center and my fluorines around it. And then I look up the electronegativities on Appendix O. Magnesium is 1.23, fluorines 4.10. So 1.23, 4.10. So I do it between one magnesium and one fluorine. And my difference is 2 point, I can't do math in my head, that's pathetic. .87. So it means it's going to be ionic. Now what I would do is I would do this again between the other magnesium and the other fluorine. Now I'm still going to get the same answer, right?
Why is it like switched?
Because you have to do it between only two elements at a time.
But like, why wouldn't you just still do it the same way?
Fluorine is 4.10. Magnesium is 1.23. So when you take the difference, and if I was going to do it between these two, now because I'm taking the absolute value, it doesn't really matter which one you do, but I just want to make sure that I match the number with the correct element. Because we've got magnesium fluoride here, but you know, it could be something like this. You could have a chlorine, a magnesium, and a fluorine. So you always do it between just two elements at a time. Now, this is why we studied quantum mechanics. How many electrons do we start with magnesium, Megan? Here's magnesium. What group is it in? 2. So it's got 2 valence electrons. How about fluorine there, Jader? How many electrons, valence electrons does fluorine have? That's the charge. Here's fluorine. What group is that? 7. So if it's a group 7, it's going to have 7 valence electrons. Now, when we're making bonds, you can move the electrons wherever you want. Okay. If it was just magnesium by itself, that's what you would do. But when you're making bonds, you can move the electrons any place you want to. So because it's ionic, the fluorine is going to steal the electrons. So if it stole one, it becomes -1. Magnesium lost 2, so it becomes +2. So for ionics, we draw brackets, okay? And there should be charges written up here. So ionics have brackets and charges. Okay. Ionics have brackets and charges. Now, what about covalent? Well, actually, let me just back up and just, Appendix F should be in your packet of appendices. Maybe it got ripped out. But there's also a copy of it. I believe if you go under, if you go into Canvas, I believe you can find Appendix F under classroom documents. Maybe, maybe not. Classroom documents. Oh, nope. I'll have to add Appendix F. But it should be in your packet of appendices. So any question on ionics before we learn how to do covalence? All right, covalence we're going to share. And if our difference is less than 1.7, and we're going to do water. The rules for covalent bonding are on Appendix F. The example we're going to do is water. So just like before, we're going to put the oxygen in the center. And the hydrogens will go around it. How many electrons, Lola, go around the oxygen? How many valence electrons does oxygen have, Lola? You disappeared. How many oxygens or how many electrons go around oxygen? How about you, Keith? How many electrons go around the oxygen? And if you don't know, that's okay too. You know, Keith?
What happened? I'm sorry. I'm looking for
Oh,
something.
appendix F. All right.
Yeah.
I'll call on Chloe. Chloe, how many electrons go around oxygen?
6.
6, because it's in group 6A. Now you can put them wherever you want because we're doing a bond. How many electrons, Drew, go around hydrogen?
2 or 1.
1. So I have to figure out if I'm going to be stealing or sharing. So I go to my chart. And I've got oxygen at 3.50 and hydrogen at 2.20. So oxygen is 3.5, hydrogen is 2.2. I take the difference, 1.3, that's covalent. So what do we do when we share? So appendix F gives me the rules. If I am in group 6A, actually, let's start off here. If I'm in group 1A, I must get 2 electrons around my element. So if I'm in group 1A, I have to get 2 electrons around. Right now, my hydrogen has 1. I have to somehow get 2. If I'm in group 2A, I need 4 electrons around it. Group 3A, I need 6. Group 4A, I need 8. And if you're in group 5, 6, and 7, you need 8 electrons. For right now, just ignore the bottom box. Don't actually cross it out, just ignore it, RJ. So again, you must follow these rules. So how are we going to do this? How am I going to get 2 electrons around the hydrogen? Well, this is where, Lars, you want to use a pencil. So I'm going to take this electron and put it there. I'm going to take this electron, move it down there. I'm going to take this electron, move it there. And then I'm going to take this electron and move it here. So now I've got 8 around the oxygen. I'm actually going to move these guys a little bit closer. So I've got 8 around the oxygen, and I've got 2 around the hydrogens. So for covalent, I draw circles. There are no charges. You don't see a +1 and a -2. Yep, really. No, you can put, when you're doing bonds, you can move the electrons wherever you want, okay? I'll upload an appendix F, Keith, okay, for you.
Okay.
I'll do that during work time immediately. And I'll put it under class documents. So here's one thing that people will do wrong, you can't have electrons by themselves. Electrons must always be paired up. Just like human beings, we're always looking for a pair, okay? This is called the line bond. So for every shared pair, you could draw a line in. So this is the Lewis dot. That's the line bond. You writing this stuff down, RJ? You want some examples. Don't rely on your memory. I'm telling you, I've done this for 22 years. I've learned a few things. So here's the Lewis dot, here's the line bond. Let's do another one. Let's do aluminum chloride. So we'll do a couple more examples and I think you'll be ready to do the homework. So how many electrons? Let's see here. Amanda, how many electrons does aluminum start with?
I have no idea.
Okay, do you have a periodic, when you're at home, you should always have your periodic table with you and have your appendices handy. So on the periodic table, oops, not that periodic table. On the periodic table, I find aluminum right here in group 3A, okay? And this is the right reason why I call on people. I'm not trying to like put you on the spot, but it helps me know where there are barriers to your understanding. And I guarantee that, Amanda, you had that question. I guarantee there are at least 4 people in this class who have the same question and they're too afraid to ask. So that's why I ask people, and I try to ask everybody at least once. It's in group 3A there, Amanda. So it's going to start with 3 electrons. Three chlorines around it. So now you have a chance to double your money here, Amanda. How many electrons go around the chlorine? How many do they start with? Yep, 7.
7.
Because it's in group 7A. And you can use any symbol you want. You can put the dots wherever you want. I am just using, so the question is, do the X's and the dots mean?
It doesn't matter which one you put in.
It doesn't matter which one you put them on. I'm just using X's for aluminum so that you know aluminum starts with 3. And I'm using dots for chlorine so that you know that chlorine starts with 7. Okay. Now let's check to see if it's ionic or covalent. So aluminum is 1.47. Chlorine is 2.83. You take the difference. 1.36. So is that going to be ionic or covalent, Mike? Covalent sharing. So then I go to Appendix F to find my rules here, Karen. When I go to Appendix F, find it. Aluminum is in group 3A, so I'm going to need 6 electrons. Chlorine is in group 7A, so I'm going to need 8 electrons. So just a reminder, 5, 6, and 7, they all need 8. So I'm going to have to get 6 around my aluminum and 8 around my chlorines. Now I've been doing this for years, so I know what to do. You guys are just starting off. Nope, I didn't add another chlorine. The example was aluminum, three chlorines. So here I'm sharing, there I'm sharing, there I am sharing. So each chlorine now has 8. And my aluminum now has 6. So these are kind of like little puzzles. And again, this is why we studied quantum mechanics, so that we knew why aluminum started with 3 and why chlorine starts with 7. And then the line bond structure would look like this. All right, one last problem, one last example, and then you're going to have the rest of the time to work on your homework. Can nitrogen be by itself? Nitrogen is diatomic. Now that we know quantum mechanics, we can start to explain why. So I got my 2 nitrogens. And Maria, how many valence electrons does nitrogen have? 5, yep. I have to first find out if it's ionic or covalent. So I go to Appendix O and I look up the electronegativity of nitrogen, 3.07. So I know it's going to be covalent because 3.07 minus 3.07 is 0. So now what's going to happen is I look at Appendix F. Nitrogen is in group 5A. So that means, RJ, I have to get 8 electrons around. That's my goal. So if I do this, how many, Sophie, does that get me around each nitrogen? 6. How many do I need? 8. So that doesn't work. If I need more electrons, Evan, I can make double or triple bonds. So I'm going to take one from there, one from there.
But how can the ones be by themselves?
They can't. Electrons are never by themselves, Keegan. How many electrons do I have right now around each nitrogen, Keegan? I started with 5, and now I have 7. How many do I need? Ocho. Oshem. So Morgan kind of alluded to this. She said, well, you can't have an electron by itself, and you're right. So guess what? Whoops. We end up with that. We have a triple bond between the two nitrogens. This is the reason why nitrogen is diatomic. And this is the reason why nitrogen forms a triple bond. And guess what? Because nitrogen has a triple bond, it's super strong. Nitrogen does not like to react. Because that triple bond is so strong, you can inhale nitrogen and exhale it. It doesn't react with your body. I get a kick out of sometimes like just this stupid stuff that's in like the news. So last year, there was a liquid nitrogen factory that had an electrical fire, and they released all their liquid nitrogen and it evaporated. So they evacuated the elementary school across the street because they were afraid of the nitrogen in the air. Do you know how much nitrogen is in the air normally? It's around 80%. We breathe in nitrogen with every breath, and we breathe it right back out. The atmosphere is only about 20% oxygen. It's just mostly those two gases. Teeny bit of CO2, teeny bit of hydrogen, teeny bit of helium, but our atmosphere is mostly those two gases. And so here they're evacuating a school because of nitrogen in the air, and the reporters didn't even question it. It's like, dude, you know, have a little basic sense of science. Okay. So, for homework, which will be due Thursday, I actually have the right due date in Canvas. Tomorrow, we're going to do a lab. Thursday is your homework. It's the Fruit Loop worksheet. And it's this guy. Where'd it go? Fruit Loop worksheet. Why the Fruit Loops? Some people find it very helpful to use manipulatives. So some people find, and this is why I said you might want to use Cheerios or Fruit Loops, because you can actually move these around. And that sometimes is helpful when you're trying to do something, to be actually able to manipulate them with your hands. So I'm not going to force you to use Fruit Loops or Cheerios, Lars, but realize that some people find it very helpful to do that. Okay, especially when we're first learning to do these. So like I said, don't do aluminum N3. For all of these, the first thing you do is check to see if it's ionic or covalent. Then you do, if it's ionic, use brackets. If it's covalent, use circles. I highly suggest you work in groups. Okay, Keith had a great question. How do you tell if it's ionic or covalent? You have to do that electronegativity difference. So you're going to need Appendix O to find the electronegativity difference first. If it's 1.7 or greater, it's ionic. If it's less than 1.7, covalent. So like I said, I highly suggest working in small groups. Definitely use a pencil. And we'll get maybe halfway on this worksheet today, and then we'll do the rest in class tomorrow. Okay? So there's no homework tonight, but I do expect you to use this time well. So I'll be walking around the room, and I will be also looking at the chat room. Keith, I'll upload Appendix F for you right now. Okay? Oh, you want to? Yeah, let's do it. I'll do it. Me and my group.
I can. I can figure out one.
If you want Fruit Loops, okay, just look at your yearbook, get it out of your system. 5 minutes of yearbook and then homework.
Picture that I got was so
I would have thought mine too. It was just her being like, what was a thumbs up? And then, yeah, people are like,
It's going to be due Thursday.
For nitrogen on this one, do we just say diatomic or ion?
No, you have to do the loose dot structure with all the dots and stuff.
What?
I'm getting one.
Bro, it was great. I didn't wait.
It looks like you got juice box, babe. You just need a little bit.
Oh, wait. I got a high top.
That's what happened. No, sure, you don't get it. No. Like that looks so round. So like this looks 100% like all of ours. Somebody get yourself to look a lot better than mine.
Herb was going through it.
Alex,
Dude, that's great on my photo. So bad.
Wait, Alex, where is it?
Oh, Drew. Okay, look at Drew's. He's on fishing. Dude, no. Luke is like, no, Luke is sexy. Luke, that is.
I'm so just oh, right here.
And look at, he was 16 and 30.
Oh, my
Yeah.
Hold on.
I really threw that over. You guys. That was like, that's a baseball game.
Yep. Sure.
With that, because I want to.
Yeah, we can do some review ahead of time.
I'm right there.
So when we take it, I'm probably gonna do it.
Oh, not necessarily. If we review. Yeah, I can do that. Do you have a open period or no?
Yeah, can I do that
Why does
tomorrow?
a freshman need to
Because I have a.
Yes. Yeah. Tomorrow would work. That would work.
I'm going oh, yeah, you know it. No, all the
Yeah. Hey, did you see Anthony's picture? It's like his 7th grade picture.
Yep.
Actually,
Let
I
me-
do this more than
Okay, this here. It's a key.
I. Sorry.
That's right.
That's right.
Like,
So then, yeah, the bigger one's a little bit, right?
Correct.
celebrating fall.
All right, for you guys at home, if you don't know where this stuff is, so I put Appendix F under classroom documents. It'll show up in a second. Bonding, there's the Fruit Loop worksheet. So if you go under bonding, there's the Fruit Loop worksheet. There's Appendix F. You can also find Appendix F under classroom documents. It'll show up in a second, but those two places, okay?
I don't know. Like, great. Favorite class, favorite color, favorite issue.
All right, I'm gonna walk around the room and help students. I'll be back in a second. I'll be checking the chat.
Why do we have to go for election?
All right, two more minutes and then the yearbooks go away, because I want you to. Why don't you have the presidential?
Why do we have the
election?
president?
Oh, you have it in there.
Yeah, for what?
Oh, that's an important part of life.
I guess.
All right, you're gonna-
I just submitted my
Yeah.
favorite meal of the day.
Oh, you already said the.
Favorite books and movies.
Yeah.
They did meet her.
I
I had a full on.
You finish the 2K barbershop and ask for that.
Girls basketball. Hey, boys.
Yeah, for Schaefer's thing, he had his cats.
Okay, gentlemen, put your books away. Put your books away, 'cause I'll make sure you get at least a couple of these. We're gonna your book away. Okay. Okay, so this is where you look at your periodic table. So oxygen is in group 6A. So it starts with 6. So because it's in group 6A, you get 8. Group 1A, you need 2. First you gotta do is electronic field. Since it's ionic, you don't follow these rules. That's only for covalent. Ionic, you just you. So oxygen, the oxygen gained 2. So it's -2. That's lost 1. So you check to see if there's so that's ionic.
What do you do then? That's the only one I
Do
do.
the H of the C, find out if it's ionic or covalent, and you start over and do it between the C and the N.
But like,
One could be ionic, the other one could be
But you have
covalent.
to do it between the H and the I.
No.
And then it's always the element in the middle of the one. You both.
oh, wait.
Yeah, in the situation. All right.
Look at me, man.
Let's do this one. You did this one like that.
One.
Yeah, I guess I'll have to.
One.
It's like that Megan in grade 9. Grade 9.
Okay, so is this one ionic or covalent?
That is one number. It's not that. The other. Oh, and then okay, 3.5 minus 3.5. That is ionic.
Yeah. Wow. This isn't even like art.
What does it mean?
Oh, that's
You're right.
I want to see these 3 things done.
Look, dude, I got.
Yeah, those are the 2 we didn't. Yes,
Wait, so we didn't finish it.
So how many is oxygen start?
8, 6.
6.
Do it.
Nope.
Oh, my bad. I looked in the wrong one.
6. That's 1. So now because it's ionic. Brackets and it's yields be like that. It's still 2, so now it's minus. Must be 1 point. Yep.
Okay. Got it. So what's trying to go back? 1, 2, 1. All right, H2O.
one has like the electro.
C,
So it's gonna be ionic. So that means the oxygen is just steal those electrons. They still have to be paired up. 2, 4, 6, 8. The oxygen is not 2 bonds, it's equal.
they both. Oh.
So what you do is you do different things. Find out if that one's ionic.
How did we get this all that? No, me and Larry.
No.
So.
Oh, wait, we gave time to.
Sodium hydroxide.
Oh, no, oh.
Oxygen's got
It's
6.
yeah, you're right. Yeah.
So what you have is. Oxygen just steals on over. So there's a plus one. So then this whole thing is 7. Minus 1, 2, 3, 4, 5. Right. So this is an example of sodium hydroxide is got an ionic bond between the sodium. And this is also the reason why OH group made carbon minus 4.
Oh, she just went. Do you think I would just put the bracket
So
around
just
this one and be like -1, or would I do like a new one? And do like -, or plus.
Well, no.
So then,
Now oxygen So how many of this circles? There are no charts.
1, 2, 3, 4.
Well, like, how does it need?
Oh, we don't know. I'm gonna have to look that up. Yeah.
No, that
Oh, all right, you guys at home, what one do you need help with?
what are you guys doing?
We're doing subtraction. She just.
Appendix O has the electronegativities, Keith. So you need that to figure out whether or not it's ionic or covalent.
Hey, look.
You could always Google electronegativity table, and you'll be able to find it. Now, the rest of you, how are you guys doing? So I'm gonna gently say that I don't believe you guys because I've done this for 22 years and I know that people get stuck. So I'm gonna do potassium oxide. So oxygen goes in the center. Potassiums go around it. Oxygen is in group 6A. So it starts with 6. Potassium starts with 1. Oxygen is 3.50. And potassium is 0.91. So it's going to be ionic. When it's ionic, you steal. So I'm going to steal those 2 electrons. And And then I put brackets and charges. Obviously, you can just go Google the answer online, but that's not going to help you. Okay, you want to learn this skill. So I know you're going to have some struggles. That's why this is due Thursday. So if you get stuck on this tonight, and we'll have work time tomorrow in class, you know, you let me know. But nobody does this worksheet and gets it completely right.
I don't know, Strauss, you might be the first.
Weston, that's a
We are
freshman.
rolling. We are rolling.
I know mine.
And I is in the one.
So I guess I'll ask again,
Right, so.
who's got a question?
Maybe they're like.
That is my fault, Abraham.
Hopefully not. Yeah, because we submitted stuff.
Oh, and for JV hockey, that we were,
Yeah,
that they were 6, that they were 12-1.
You're right, you're right.
All right, I'm gonna go walk around and help them, and I know that the people in class have tons of questions.
That's an A. That's an A. He's like a first. Because of the black, what do you feel? How many did you see all? 8? Oh.
Carbon starts with 4.
We may start from.
These guys start with 7.
Is it 8?
Basically, I'm coming.
Okay. Oh, this one, a little line. Yeah, we have that.
So that means steel,
We do that.
steel that electron.
That's what I'm saying.
So that has to be 1 minus another B. Would you listen to my song when I sing about the love song between sodium and chlorine?
No. I was focusing on your screen, not the lyrics. Oh, how do we subtract 3 numbers?
We just do all of them.
Oh, the biggest, the next biggest is long.
No. Yeah, they both. Yeah. And then they'll just go away.
Ow.
I don't know, I just kind of did the plus and then plus.
That's right.
And then plus on.
So then that makes it easy.
I would rather be able to.
Oh, see, this issue. How are we gonna get 8 carbon? No, oh, you only need 6. Oh, no. No, carbon?
You know. Yeah, okay, well. I know, he can just be like, super mean, or he can just be like,
All right, Larry, you ready to go?
I don't know, he will like compliment you sometimes, and I'm like, okay, well, I mean, I actually